Very good day to all lecturers. My name is Ridwan and today I'm going to do a presentation of my Game AI project. And before I show my game, I'll show you my finite state machine diagram. So here's an updated version of it. I've removed the end state, and my game is actually a coffee making game called Crazy Cafe. And so the process is that the player puts the cup in the machine, adds some powder, adds some water, adds some milk, brew the coffee, and then serve it to the customer. And as the game goes by, and the player fails the quick time event, the machine will go into catastrophe such as the machine being frozen, burning, being dirty. And also at any point of time, if the player removes the cup from the machine, it will, from these states, will actually go back to the machine being ready. And I also made some changes to the customer FSM, remove the end state and loop the customer back to the enter state once it has left the store. So here's a comparison of my old one. As you can see, there's no way to remove the cup, and only being able to remove whenever the broom is complete. Also remove the end state, as you can see, so it loops back to being machine ready. And for the customer FSM, you can see that there's no end state and it loops back the customer entry. So now let's see my game. So basically, the game runs on a point system, and in this case stars. Whenever the player does the correct order, it will score a point, and whenever it doesn't satisfy the customer, it will lose a star. And once you get 0 stars, the game will be over. So I'll go through the main UI first. Here is the customer's current state being displayed. Here's a timer that decreases whenever the customer is waiting, and whenever the timer comes 0, the customer leaves the shop and will enter once more. So here here's a reaction of the customer. Here's the customer's order. Here's a hint that will prompt the player of what to do in the current state. Here's a progress bar that will increase when certain actions occur, and here's the quick time event bar that I will demonstrate later. Here's the current state of the machine, the coffee machine. Here's some other variables of the machine that will be displayed. So you have the option to add powder, add water, add milk, mix coffee, brew coffee, change the coffee type, and change the brew mode. So here we have a serving tray to serve to the customer. We have some objects that can be used to fix some catastrophes that's happening in the machine, and a rubbish bin to reset the state of the coffee cup. So the two main finite state machines are the coffee machine and also the customer waiting. So let's restart the game and let's go through what we can expect in the game. So at first, the customer enters the shop and would have this order. So you can drag the coffee to the coffee machine cup holder, and you set the cup machine to be true. So when you trigger this add powder, this will move, and if you fail to do so, and if you fail to click when it's in the region, it will cause a problem in the machine. So right now the machine is dirty, so you have to use this cleaner and put it in the fixed machine drop area. And the progress bar will trigger, and once it's complete, it will go back to the state of being ready. So once it's ready, put the cup in the cup holder, can add powder. So now you can see we landed in the region. Now the powder is added. Now we should add some water. Okay, now we should add some milk. So now the milk is being added. So now what we're going to do is to mix the coffee. So once we are done with the mixing of coffee, we need to brew the coffee. So based on the customer's order, we need hot mocha. So let's change it to mocha and the brewing mode to be hot. So now let's brew the coffee. Alright, now you can see that the state changes as it goes as well. So when we have a hot mocha, we serve it to the customer, and the customer will add a score to our score counter. So just to demonstrate the other catastrophe, so first catastrophe is the machine being dirty. So as you can see here, if I fail the event at any of these three states, it will cause the machine to be dirty, so I need to clean it. So the two other catastrophe would be caused by the brewing of coffee and also the brewing mode. So to demonstrate, let's make the coffee machine burn. So right, we are now in machine ready. So let's add some powder, add some water, add some milk, mix the coffee. So if we were to make some hot mocha, and so we brew the coffee, and if we were to fail it, we need to use the coffee machine will be burning, and we need to use the fire extinguisher to fix this. So fix this. Right now, then we can redo the coffee again, and if we make it cold, we want to be cold and fill it. So that's what will happen. So the machine will be frozen. So I need to use the flamethrower to heat it up. So okay, let's get this order, hot latte. So let's brew the coffee and serve. Serve. Oh, I guess our rating goes down. So this is actually supposed to trigger the game over function. And let's just see. Okay, currently the game over function is not being triggered. It's actually supposed to trigger a game over function, which is basically just a layover of the canvas, just like this. You actually display the score that you've reached once the rating goes to 0, and you can try again, which looks the same. Now let me go over the codes of how I implemented this. So the scripts structure goes like this. We have the finite state machines and the states under this FSM file. So let's open these 4 files. So the first of all, we have the CMFSM, which is the coffee machine's FSM. At first, we have a enum class to declare all the states of the coffee machine. Also use a singleton to actually we also make it a singleton so that other scripts, there are multiple scripts that will be referencing the current state of the finite state machine. So over here, before the start function, we declare all the states of the machine. And before we go over that, let's go over to the state of the coffee machine. So here is the abstract class of the ICM state, and it's made to be an abstract class for good object-oriented programming, and it has 3 functions that can be overridden: enter, execute, and exit. So we have a reference to the state machine as well, which will be passed in when the state is being initialized, and also an enum to keep track of the new state that the machine will be transitioned to. So continuing on in the start function, I've actually also declared a list of states that will make the changing of states easier later on. So we initialize all the states instances. and we also added each state into the list that we have made previously. So once we have initialized all the states, we make machine ready to be the current state, which is the first ever state after the enter, and we enter the current state. So in the update state, it will execute whatever's in the executes function of the state, and we've also called a function called change state, which passes in a state parameter. So this will be called in the state classes, and once it's being called, it will exit the current state. It will change the state using the list. We cast the enum into an integer, and we actually make it reference the state that is being passed in, and it will enter the state that is being changed to. So this is similar for the customer as well. We have these 4 states: make it a singleton, declaring of states, changing of states. So here's also an abstract class of the customer, which is similar to the coffee machine. With enter, execute, and exit. So next, let's go over the coffee machine states. So let's refer to our final state machine. So the first state is machine ready. Let's get that up. So here's machine ready. I'll just go through very quickly. So it's the initializing, it passes in state machine, and state machine is being inherited from the abstract class. So we have the state machine. So once you enter, we'll change, it will set the state of this, it will reset this boolean of the customer. Basically, it will update the hint, it will check if the cup is removable, and in the execute function. So basically how I see how this final state machine works is that every state will have a start function similar to AT's API start function. The execute function will somewhat be an update function. It overrides the functions in the abstract class. So in the execute function, we'll check if the button is pressed and the cup is in the machine, and if it's true, we'll change state over to adding powder. So in adding powder, it actually, so the triggering of the QuickTime event, which is this bar over here, I actually use a delegate to actually call back once the player hits the pointer inside the region or the pointer passes the region. And how I did that is by, let's go over to the QuickTime event, which is over here. Using system, I call this make this event callback of type boolean delegate to be declared here. And this trigger QuickTime event will be called by the script, as you can see here. So once it enters, so this adding powder will be triggered whenever the player presses the add powder button, which is over here, add powder. So whenever it triggers, this QuickTime event is being triggered. So once it is being triggered, it will start this coroutine, and this coroutine actually increases the value of the slider. It actually uses a slider over here, and once it has passed this counting up of the value, you'll actually check if it's within the region. If it's actually within the region, it will actually call back to the event callback, which is actually set over here and being passed as a parameter, and so it will return true if the player passes the pointer in the region, and it will fail so if the player fails to. So over here, you can see that it triggers this callback delegate event. So we have the adding powder event, which is this one, and it's a type of function that has a parameter of boolean. So based on this, if it's true or false, it will go to the states, change to the according states of true or false. So powder added or machine dirty. As you can see here, powder added or machine dirty, and is based on QuickTime event fail or pass. So that will be similar. So let's see what happens if it goes to powder added, which is powder added, yeah. So and since I've made some changes, which is this, so every time the player removes the cup, it will go back to machine dirty. So from powder added, it will go back to machine ready, and else it will, and if the player presses added water, it will go to adding water. And that is for the QuickTime event. There's also a progress bar, and how that works is that, let's go over to the script. So as you can see here, it also uses an delegate event right here, a callback. So instead of having a type of boolean, it's just a function with no parameter. So it just starts the coroutine, and once it has counted down, it will call back the event. As you can see, this will be seen when you are trying to clean the machine. It triggers the progress bar, and once it is completed, it will call this function, and it will change state to machine ready, which is this. So adding machine ready, adding powder added is similar. It's a similar pattern to these three. Powder added, adding water added, adding milk added. So from milk added to coffee mixing, it uses the progress bar to see if it's complete. And from brewing ready to coffee brewing, it uses the QuickTime event, and is dependent by the brewing mode, cool or hot. So if it's this side, we make the machine frozen. If it fails and it's hot, it will cause the machine to break. So once the coffee is successfully brewed, it will be complete. So that's basically most of the states and how the state changes happens. And so how I structure the game is that there's a finite state machine, states, and also entity managers. What are entity managers? I have one for the coffee cup. This doesn't really have a finite state machine, but it has different states to show the current state of the coffee cup. As you can see here, if I put it in the machine and add some powder, it will actually change the state of the coffee cup accordingly. So here's an entity manager for the coffee cup. Next up, we also have the coffee machine. Basically, it has a few booleans to check if the button is being pressed or an object is being dragged into a slot. So you can see the pressing of the powder and the pressing of the water button. Press the button, mixing the coffee. Basically, okay, for the pressing of the water button, see that the current state is powder added. It will set the boolean to be true. However, if it's adding water, which is where the QuickTime event is passing, it will set event active to false. The QuickTime event active to false, which will actually stop the pointer. And it will be the same for most of the buttons. Press flame forward button, which is actually called when you want to drag a flamethrower over to this fixed machine drop area, and most of it are just the pressing of buttons. Add cup to machine. It's happening when the cup is added to the cup holder here. Toggle or brewing mode, which is simply just changing your booleans. Toggle of top coffee type. There's also the pressing of cloth button, which is actually cleaning the cup holder. And so we also have a manager for the customer. We also use callback here for the customer to actually move, and also this waiting bar, which actually occurs when the player, which is right over here. See, when the customer enters this state, it will actually be waiting, and it will leave when the timer becomes 0 or the player serves the coffee. So as you can see here, the customer is being served. It will manage the customer and it will stop the customer from waiting. And over here, this fixed update is just the visual effect of the player moving, of the customer moving in and out of the frame. And this actually checks if the coffee that the player brew is actually corresponding to the customer's order, like the one over here. And there will be four different combinations, which is latte and mocha, and whether it's hot or cold. And there could be a possible combination where the player serves the wrong order and the ratings will be decreased. However, if the player gives the right combination, the score will increase. So if the customer is not being served, there's also a possibility as well. And the resets will be, the statistics, the variables will be reset every time the customer enters the scene. There's also a UI manager, which basically updates all the UI elements. Very basic. Item manager, which allows us to actually set item position once it's being dragged and out. So final part over here is the drag handling. I've actually used iDrop handler interface, which is part of the Unity event system. So basically, it consists of the slot script, also the drag handler script. So I've added this function which actually resets the position of the object once it's been moved. It can be reset to its original position. So whenever the player starts to drag the object, it will set the item to be the game object. It will store the position and start preparing for the object, and on drag it will set the position to the mouse position, so it will look like really like this, where the object position is set to the player's mouse. Next up, so once it has ended the dragging, it will actually see if the slot that is being dragged to is appropriate to be dropped into. So this is where it is being checked on drop of the iDrop handler. So I've created this function which actually handles what to call whenever, based on the tags that are given to the different entities. So that is basically it for my presentation. Thank you.